Welcome students to another interesting chapter, that is quadratic equation. My name is Sachin Gadkar and I will be taking you through this interesting journey of quadratic equation. Now quadratic equation is a very important chapter as much as the entrance exam is concerned, both the JEE Mains as well as JEE Advanced. So let's begin this interesting chapter. Now here in this first module we'll be touching on three different aspects of quadratic equation, and they become the most important aspects, wherein we first touch with the definition of a quadratic equation, then we go to the idea of degree of a quadratic equation, and finally we end this module on fundamental of algebra. Now as it is saying fundamentals, it's really very fundamental as we discuss going further. Now the first aspect here is the definition of a quadratic equation. Now any equation of the form ax square plus bx plus c equal to 0, where a, b, c are real numbers and a is not equal to 0. Believe me friends, till now at school level you never gave importance to the conditions which come in a definition, because obviously they were not asked in the exam. But henceforth please try to concentrate a lot on the conditions given in the definition, because those are the things which will get you out of ambiguities. Okay. Now any such equation as stated on the screen is called as quadratic equation with real coefficients. Now first of all let us analyze why the conditions are given. It's very important. Now if you see here, ABC are given as real numbers. Well, ABC could have been rational numbers, irrational numbers, imaginary numbers, anything. But as much as our syllabus is concerned with respect to JEE Main, JEE Advanced, ABC have to be taken as real numbers, so that we study quadratic equation with real coefficients. The name suggests that why ABC are real numbers. Now if you see the next condition, that is A is not equal to 0. What if we actually take A as 0? If A is 0, what happens is, see the expression ax square plus bx plus c, ax square will vanish because A is equal to 0. Now as ax square vanishes, we have bx plus c equal to 0 equation. Now what were we studying basically? We were studying a quadratic equation, and now what is left with us? Bx plus c equals 0. It's a linear equation, and now you know why A is taken to be not equal to 0. And as we see more formulas going further, it will be more clear why A is not equal to 0. So now let us go further in this whole discussion. This was definition. Now let us see one more part of the definition, that is power over x have to be whole numbers. Whole numbers means the powers can be 0, 1, 2, 3 and so on. This also becomes a very important aspect of the definition of a quadratic equation. We'll again use that in an example to clarify more. Now let us try one more example, a few more examples. The first example comes here on your screen. 2x square plus 3x plus 4 equals 0. Is it a quadratic equation? First of all, let us see the values of a, b and c. They are 2, 3 and 4. They are real numbers. 2 is not equal to 0, that is coefficient of x square should be not equal to 0. So it satisfies the definition of quadratic equation, and hence we conclude that it is a quadratic equation. Let us see the next example. Root 3x square plus 7x plus 2 equals 0. Here also the coefficient root 3, 7 and 2 are real numbers. Again it is satisfying the definition of a quadratic equation, and hence we say that it is also a quadratic equation. Okay. Now let us see the next example. This is very interesting. X plus 1 by x equals 2. Now most of you will feel that it's a quadratic equation because when you multiply throughout by x, you will see that it turns out to be a quadratic equation. But please remember that whenever you see a problem, it should be the original problem on which you are applying the definition. So here if you see the power over x, do you remember another way of looking that note which we gave our definition? Here 1 by x can be actually seen as x raised to minus 1, and we know that power over x in a quadratic equation should be whole numbers, and x raised to minus 1, the power is negative, it's not a whole number, and hence we conclude that this is not a quadratic equation. Fine. So with these examples I hope you know how to use the definition. Let us move to the next idea, which is called degree of a quadratic equation. Now what is degree of a quadratic equation? Among all whole powers in a polynomial, the highest power is called the degree of a polynomial. Okay. Now with that idea, with that definition, can we say what is degree of a quadratic equation? What is the degree of a quadratic equation? A quadratic equation has highest power 2, hence the degree of a quadratic equation is going to be 2. Okay. Now let's see one more example of a polynomial. You see here a polynomial which is x cube plus 3x square plus 2x plus 1 equal to 0. Now what's the degree of this? particular polynomial. The highest power among all whole powers is actually 3. Hence we say the degree of this particular polynomial is 3. It is called a cubic polynomial, for your information. Now let us go further to the next very important idea, as the name suggests, it's fundamental of algebra. Now, in what is the idea of fundamental of algebra? Any polynomial, please remember, any polynomial with degree n. We know what is degree? Highest power among all whole powers in a polynomial. So any polynomial of degree n has n roots. It's very easy to remember, right? Yeah. Now, so by that logic, what do you think quadratic equation will have how many roots? Yes, the quadratic equation has degree 2, so the number of roots are going to be 2 by fundamental of algebra. But please remember that fundamental of algebra helps only if it's a polynomial. Now let us see this with an example. You have a cubic equation in front of you, x cube plus 3x square plus 2x plus 7 equals 0. So here the highest power is 3, so the degree is 3, and so how many roots this cubic polynomial is going to have? 3 roots. Okay, thanks to fundamental of algebra. Let us see the next example. Do you remember this is similar to the problem which we saw some time back? X plus 1 by x equals 0. Now here, how many roots does this particular equation have? I have said equation, I didn't say polynomial equation, I just said equation, because first of all, is it a polynomial? We have seen this particular example. If you see, 1 by x can be written as x raised to minus 1, and power over all x in a polynomial has to be whole numbers. So first of all, this particular equation is not a polynomial. Yeah, and for fundamental of algebra to help us, we need a polynomial, and hence we say that the number of roots for this equation cannot be commented. Yeah, so I hope you are clear with the usage of first the definition of a quadratic equation, for that matter a polynomial, then we came to the idea of degree, and finally we are closing this module with fundamental of algebra. Yeah, so thank you students, for we have come to the end of this particular